What's up guys, Andy here, and we are starting the From Zero to Hero journey. I've chosen the perfect problem to be the icebreaker of this series because it has a super simple idea behind it, but it can be tricky. So, this problem could be tagged as an array problem or even a dynamic programming one, but it's actually very natural. So, it's called DZY loves sequences, and let's read the statement together. So DZY has a sequence A consisting of n integers, which is actually an array. Now we'll call a sequence ai plus 1 dot 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 aj with I less or equal than j a subsegment of the sequence A. So basically this is a subarray, right? This is the definition of a subarray. Now the value j minus I plus 1 denotes the length of the subsegment. Obvious. Your task is to find the longest subsegment of A such that it is possible to change at most one number, change one number to any integer you want, from that subsegment in order to make it strictly increasing. And you only need to output the length of the subsegment you find. Perfect. So, I basically have an array of n elements and I should choose a subarray which is valid. And a valid subarray means that I can change only one element max from that subarray to any integer I want in order to make the subarray strictly increasing, which is quite nice. Now, let's check this example, and we are going to be simplistic here and we are going to use the notepad. So I think I've written some notes here, but let's start it all over again. And our array, let's see what values it has: 7, 2, 3, 1, 5 and 6, right? So for this the answer is 5. And why is that? Because our solution is actually this subarray from position 2 all the way to position 6. And if I take these values, it's obvious that I can change the 1 to a 4, and now this subarray is strictly increasing, right? So here, let's say here, my answer is going to be 5, which is perfect. Now, let's take the initial array and think about this problem, right? So 7, 2, 3, 1, 5 and 6. Perfect. Now, what I always like to do is first of all look at the restrictions of the problem. And I see there that the first line contains an integer n, which is less or equal than 10 to the power 5. Which means in order to have an accepted solution, right, I can't have a brute force approach in big O of n squared. That's way too large. So I need to be smart about this. Now, if I want to, let's say, have a brute force approach, that's actually quite simple if you think about it, because when we have an array of size n, how many distinct subarrays this array would have? And the answer is big O of n squared. So what I can basically do is fix that subarray. So I should fix the left pointer, then I should make another for loop and fix the right pointer, and I should check if only one number is, let's say, the missing piece of the puzzle, right? So it's going to look something like this. As I written there, so a brute force in big O of n squared, it's going to have the first for loop, which is going to fix me my left pointer. So starting at position 1 all the way to position n f++. By the way, we are going to code this in code blocks, but this is just for the fun of it, for the brute force approach in Notepad, let's say. So if I have here the left pointer, okay, let's open some brackets. And what shall I do? Well, my subarray is going to start at position left. So I should go as long as I can, as long as this subarray from left to, let's say, a pointer right is strictly increasing, right? So I shall go with my right pointer, starting from left plus 1, right? Right, as long as right is less or equal than n, and one more condition, very important, in order for this to be strictly increasing, always a of right should be greater, strictly greater than a of right minus 1. And a of right is strictly greater than a of right minus 1. What should I do? Always right plus plus. So, after this for loop successfully finishes execution, I have the left pointer, which is the beginning of my subarray. I go all the way until I find an element which basically makes the subarray invalid, right? Which is less or equal than its previous version. So that is the element that I should change, obviously, right? So I should change it to some value which is between the previous element and the next element, right? So if I should change here a of right, the new a of right, its new value, right, should be somewhere between a of right minus 1 and a of right plus 1. So let's be a of right minus 1 plus 1. And now from left to right everything is strictly increasing. But I should make sure of one thing. This thing can happen only if a of right plus 1 is greater than a of right minus 1 plus 1, right? Because, I don't know, let's take this example. If let's say I had here 3 and a of right, which is the current element, is 3, and let's say a of right plus 1 is 4, I can't do that, because what I basically do is I see, okay, this 3 is less or equal than the previous 3. So I should make it at least 4, but when I make it 4, the next element is 4 too, and that should be at least 5, right? So only if a of right plus 1 is greater than a of right minus 1 plus 1, I can do this. So what I have to do here is, after I find the first missing piece of the puzzle, which is now a of right, I should check if, first of all, if right becomes equal to n, that means that I should change that element and I don't have a next one, so the whole subarray is going to be valid, right? So if right becomes equal to n, let's say, that's basically it. Answer is maximum between the answer and n minus left plus 1, right? I change that element and that's it. But if not, else, I should be very careful. I should check if a of right plus 1 is greater than a of right minus 1 plus 1, and if it is, this is perfect, because now I can change that a of right to be a right minus 1, everything plus 1, and I should go and check for the next elements for the strictly increasing array, right? So what will I basically do is that now I am going to start with my for loop. So my right is going to start now from its previous value plus 2. Alright, so I know that a right minus 1, a right and a right plus 1 are now okay with each other. So I go from right plus 2. Again, as long as right is less or equal than n, and this a of right is strictly greater than a of right minus 1, and I just increase my right. Perfect. Now, after this for loop finishes execution 2, let me make this a little wider so you can see. After this for loop finishes execution 2, I know that the left is the start of the subarray, and now this right is the end of the longest valid subarray, which starts at position left, and I made only one change, right? So now I will have answer is max between answer and right minus left plus 1. Right minus left plus 1, right? So what I basically do here is that this answer is initially going to be some variable, initially equal to 0, and this variable is going to hold my answer of the problem, right? So the length of the longest valid subarray. And I always update this answer, and in the end I will return the answer. So obviously this is not the full code for the brute force, but this is like a blueprint, all right? This is how it's going to look in the end. So for loop for left, go as long as I can, find the first bad element, change that if I can, and if I can I go all the way until the subarray is valid. When it's not, I found the left, the right, and I update my answer. Perfect. But remember, this is still a brute force approach. So we are going to need a linear solution for this one. Big O of n, right? So our optimal solution is going to be a big O of n. And let's think about it. For the big O of n squared, we have fixed the left and the right pointers. And then we have found basically by hand, by iterating with our for loops, we have found what is the bad element and changed it. Now, if I want a solution in big O of n, I can't fix both the left and the right. because that's too much time. But I can fix another information. I can fix what is going to be the position of the bad element. What is going to be the bad element that I'm going to change? So let's call this position P. I can basically make a for loop, let's say, from P with 1, P less or equal than N, P plus plus, right? So what I'm doing here, what this means that I am going to change the value of AP, right? So I suppose that AP is the first bad element. What does it mean? Well, if AP, let's say, all right, let's write these elements, A1, A2, A3, dot, 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 AP minus 2, let's say, A of P minus 1, let's say, A of P plus 1, A of P plus 2, and so on until AN. If this AP is going to be the first bad element, that means that starting at position P minus 1 and always going to the left, these elements are always going to be strictly decreasing right now until some position left, let's say, right? Then, if I look at the right of the element AP, starting from position P plus 1 and going each step to the right, these elements are going to form a strictly increasing sequence, right? So, let's just take the example with the 7, 2, 3, 1, 5, 6. If I take this 7, 2, 3, 1, 5, 6, basically what I do here is I suppose that the element that I change is at position 4, because this is actually what happens. So P equals 4. Then, when P equals 4, what do I know? That starting from position 3, I will have a strictly decreasing subarray. And that's right. If I look at position 3, I have the value 3, which is good. Then, if I go one step to the left, I have an element 2, strictly decreasing, perfect. Then, if I go one step to the left, I get 7, and here I stop, because this is not strictly decreasing anymore. So, I have the subarray 2 and 3. Then, if I look at the right of position 4, right, I got 5. One more step to the right, I got 5 and 6, which is great, strictly increasing, and then the array finishes, right? So, if I am to change the element at position 4 and make it the value that I want, I can then add to this element, I can, let's say, form the subarray with this element, with those elements in its left, which are strictly decreasing, and those elements in its right, which are strictly increasing, right? So here, I choose to make this element at position 4 to be a value 4, and then I can union myself with the 2, 3 from the left, and with the 5, 6 from the right, and here is my array. So my solution is going to be of length 5, right? So this is basically what happens. When I'm at some position P, I should always know what is the length of the maximum subarray starting at position P minus 1 and always be strictly decreasing, and what is the length of the maximum subarray starting at position P plus 1 and always be strictly increasing, right? So I'm going to need those informations. And because I already fixed the position P, which is already a for loop, so big O of n, I am going to need those informations in big O of 1, in constant time. And how will I get those in constant time? That asks for a pre-computation. So, step number 1. I shall pre-compute, right? So, pre-compute. What should we pre-compute? Well, we have two informations, as we said. The first one is going to be, let's call this, I don't know, max left, right? So max left of position I. This max left is actually the maximum length, right, of the subarray. And let's call this subarray. Basically, it's going to start at position I minus 1 and always going to the left. So, if its length is going to be L, for example, this subarray is going to be from position I minus L all the way to position I minus 1, right? So basically it's going to be the max L such as the subarray from position I minus L to position I minus 1 is strictly increasing, right? So A of I minus 1 is greater than A of I minus 2, which is greater than A of I minus 3, and so on, A minus L, right? And this A minus L is now less or equal than A of I minus L minus 1, right? So basically the maximum length, such as those elements, are always going decreasingly, strictly decreasingly, right? And just as that, the max right, which is basically the same but in the other direction. So the max L, let's say, such as the subarray. Now it starts with position I plus 1, so A of I plus 1, and this is going to be less than A of I plus 2, so I plus 2, less than A of I plus 3, less than, and so on and so forth, until A of I plus L, and that's it. We should pre-compute this max left and this max right. And why do we need them? Because after we manage to do this, we are going to apply the step number 2. And the step number 2 we've just discussed. We are going to fix the position P of the element we are going to change, right? So fix this position P of the element we are going to change. And if we fix that position, we should ask ourselves the following thing. Well, can I always change this position such that it's going to be okay in the end? And not always. Because if I change the position P, alright, well, I can use the subarray starting at some position left until the position P, or starting at position P until some position right. But if I want to use, let's say, a subarray starting at position left, which is less or equal than P, right? Or even less than P, and P is less than right, I should check one thing. If A of P plus 1 minus A of P minus 1 is greater or equal than 2. Because again, we have the example in which, let's say, I have 3, 3 and 4, right? If P is this element, this position, however I will change the P, I can't have a sequence that will start at least here and end at least there, right? Because if I change this to a 4, it's still not valid. If I use a 5, not valid. If I use a 2, not valid, right? So the property, in order for this to happen smoothly, is that A of P plus 1 minus A of P minus 1 should be greater or equal than 2. And if the difference is okay, then what is going to be my answer? Well, I am going to, if this is the position P, I am going to take the valid subarray ending at position P minus 1, which has length max left of P minus 1, plus one element, which is my P, the position P, and then I'm going to take the subarray starting at position P plus 1, which is valid. So max right of P plus 1. Perfect. This is okay. So step number 1 should be performed in linear time, and then step number 2 obviously is linear time. So how should we compute the max left of I and the max right of I? We will do this using a for loop for each of those. So let's start with the max left, right? I need those subarrays to be alright. So think about it this way. If I iterate through each element, starting at position 1, all the way to my position n, I++, what do I have to do? Well, first case scenario, if I is equal to 1, so is the first element of the array, obviously, or A of I is less or equal than A of I minus 1, max left of I is going to be equal to 1. As simple as that. Couldn't be greater than 1, right? That's obvious. Else, if it's greater than 1 and A of I is greater than A of I minus 1, that means that max left of I is going to be 1. So this current element plus the valid subarray ending at position I minus 1. So max left of I minus 1, right? It's basically the continuation of that subarray. And this is for the max left. For the max right, as you guessed, we are going to do the same thing, but we are going to start from position n and going to the left, right? So each time decrementing this I. And again, if I is at position n or a of I is how? Less or equal? So wait, this should be strictly increasing. Alright, so, and this one is greater or equal than a of I plus 1. Obviously max right of I is going to be 1. Else max right of I is going to be 1 plus max right of I plus 1. And that's the solution, guys. It's linear time, which is super good. Now let's open our editors, code blocks, create a new project and console application. We'll use C++ and I don't know, let's call it DZY strings or something, right? So I'm going to walk you through my implementation of this. Now, what shall we do here is we first of all have to read this input. So we are going to remove this line and read our array. So first of all, read its size, which is n, then read each element with a for loop, right? So starting from 1 all the way to n I++, we are going to read our array, which is a. Now let me define those. So n and a of n max. And for n max, I'm going to use a const integer n max of size 100,005, right? So always make the size greater just to be sure. I index my arrays starting at position 1, so I need at least one extra element for every array I define, right? So after I read this array, what shall I do? Well, let's compute max left and max right. As I said, actually, I'm just going to take the code here because I don't see any use in writing it again. It's okay. Let's indent it. Perfect. Right. Now we are going to compute this max left and max right. So let's define those two. So here I have my max left of n max and my max right of n max 2. Perfect. Max left, max right, super good. Now after we compute this, what will we do? Well, again, I will take the code because it's time for the step 2, which basically fixes me my position. All right, so let's write this code for this one actually, because I don't have it. I will fix the element which I'm going to change. So for position p from 1 all the way to n p++, right? Let's think about this. I want to change the position p. Well, when I change the position p, I can do three possible solutions, right? And those are, I can start at some position left and go all the way to the position p, or for my answer, for my desired subarray, I can start at position p and go all the way to some position right. Or the last possible outcome is I can start at some position left and end at some position right, in which obviously left is less than p, which is less than right. So let's take the first case, left p. For this, what I have to do? Well, let me do one thing first, because I should define my answer variable. Now it's okay. I should update this answer to be the maximum between its current value and 1 from this element at the position p that I'm going to change, plus the max left of p minus 1. And that's for the first possibility. For the second one, p and right, I am going to update my answer to be the maximum between answer and 1 plus max right of p plus 1, right? So this is the second possible scenario. And for the third one, I should check if it's possible to have this outcome. So a of p plus 1 minus a of p minus 1 is greater or equal than 2. And if it is possible, I'm going to update this answer to be the maximum between answer and, guess what, 1 for my element, plus I'm going to merge this with the subarray on my left, which is max left of p minus 1, and with the subarray on my right, which is max right of p plus 1, right? So max right of p plus 1. Perfect, and that's it. In the end, what shall we do? We will just print our answer. And that's it, guys. Let's hit F9 and try this code. Fingers crossed, let's hope it compiles. And it does. And what was our example? It was 6 elements, 7, 2, 3, 1, 5, 6. So 6 elements, 7, 2, 3, 1, 5, 6, 5. That seems right. Perfect, guys. This was the first video of the series From Zero to Hero. I really hope that you enjoyed and understood my solution to this problem. I think it's super beautiful and it's a very good problem to start. And if you think these videos are useful and provide some value to you, make sure to hit the subscribe button. Make sure to hit that ring bell in order to be notified when I post. Make sure to like the videos. And the best thing that I could advise you is make sure you join our Facebook group, because I created a mastermind in which I want to share one challenge a day. I want to share some pieces of advice from my knowledge and experience in competitive programming and interview questions. And we are going to grow to be a big community to help each other out. So, if there's something unclear about this problem, about my solution, make sure to post in the comments. If you have any suggestions about what you'd like to hear me teach maybe, or what kind of problems you'd like me to solve, or maybe you have one problem that's really super interesting and you want me to help solve you and post it then on YouTube, I'm super excited to hear about it. Post it in the comments and I can't wait to see you on the next video.